All right, this is Honors Algebra 2 Pre-Calc, and we are doing 4.4, which is solving systems of equations with matrices and a calculator, and we're going to go ahead and proceed with example 2. So we have the system here, right? It's a hot mess. It's completely out of order. We're asked to write this as a matrix equation and then solve the matrix equation. So first thing I need to do is put everything in order. This 5x is in a bad spot. It needs to get added to the other side. This z is in a bad spot. So I'm going to start by adding that 5x to the other side. So my first equation is now going to be a 5x plus a 2y minus a z equals a negative 7. Right? The second equation was already in order, which is convenient, right? Plus 2z equals 0, right? And then the third equation, when I move the z over, notice it doesn't have any x's, so I can put a 0x if I want, or I can just leave it blank, plus 3y plus z equals 17, right? So now when I make my coefficient matrix, it's going to be 5, 2, negative 1, 1, negative 2, 2, 0, 3, 1. My variables are going to be x, y, and z in that order, right? And interesting side note, if you're having trouble seeing why this matches the equations, let me just show you for a sec, because it just occurred to me that maybe some people are having some trouble seeing why this is the same thing. Check what happens if you were to multiply this. If you multiply this is a 3 by 3, and this is a 3 by 1, right? We know that the, just a 1, right? We know that the inner dimensions match, so the result is going to be a 3 by 1, right? We know that if I multiply this guy by this guy, I do the first thing, like the first entry in this row by the first entry in this column. Well, that would give me a 5x plus the 2 times the y. Well, there's my 2y. Plus the negative 1 times the z. Well, there's my negative 1 times z. Equals the thing on this side. Oh, look, that's so this is basically matrix multiplication, right? Just to show you that's why it works. And if you were to take and do the next entry would be this row, right, times this column. Well, wouldn't that be a 1 times the x, which is right here, a negative 2 times the y, which is right here, a 2 times the z, which is right here, equals a 0, right? And then if you wanted the third one, right, you'd take this row times this column, and you do 0 times x, well, there it is. 3 times y, well, there it is. 1 times z, there it is, and equals a 17, which is right there. So just to show you that's why it works the way it works, if you were having any trouble picturing it. So anyway, if you weren't having trouble, you probably didn't need that, but that's why it works the way it works. So I'm going to go ahead and put so this is my, oh, sorry, didn't mean to do that. There we go, sorry. All right, I'm going to go ahead and put that this is my A, right? This is my variable matrix X, which we usually write with like that weird Roman numeral thing. And this is my coefficient, or my constant matrix B, right? So coefficients, variables, constant. So in order to solve for my X, Y, Z, I'm going to have to do A inverse times B. And that's it, right? And I already have A inverse times B in my calculator. I just need to change what my A and B values are. So I go to second matrix. I go over to edit, I pick A, it's now a 3 by 3. It's a 5, a 2, and a negative 1. A 1, a negative 2, and a 2. A 0, a 3, and a 1, right? And then I double check it's right before you quit out, right? So 5, 2, negative 1, 1, negative 2, 2, 0, 3, 1, and then you quit out, right? And then you're going to go back to second matrix. You're going to go over to edit, you're going to pick B. B is a 3 by 1. Right, and you want it to be a negative 7, a 0, and a 17, right? And then you double check that that lines up right, you quit out, and then you already had A inverse times B, so you just hit enter, and you end up getting this answer. Excuse me. So you get this. So your answer is that X is negative 2, Y is 4, and Z is 5. All right, let's go ahead and try P2. So you're going to try the same thing. You can pause me if you want to do it without me. So first thing I need to do is move some stuff around. This guy's on the wrong side. These guys are on the wrong side. This guy's on the wrong side. So negative 4x plus 2y minus z equals negative 3. 2x minus y plus 3z equals negative 6. Negative 2x plus 3y minus 2z equals, oh, and this guy was also on the wrong side, a positive 1. Now, interestingly enough, this third one, you could have gone the other direction and moved the y over and said, hey, he's on the wrong side, everybody else is fine. Then you would have gotten this. I promise it's going to come out, sorry, that would be a minus 3y and a plus 2z. It's the same equation, it's just multiplied by a negative 1. So if you'd done it that way, it would be fine. I make my system of equations, right? Negative 4, 2, negative 1, 2, negative 1, 3, negative 2, 3, negative 2. My variables are x, y, and z in that order. You don't have to put them in that order, but whatever order they're in up here, they need to be in the same order down here. Negative 3, negative 6, and 1, right? This is my a, right? This is my b. So in order to solve, my x, y, z is just going to be my a inverse times my b, right? And so I'm going to type those in my calculator. And again, most of my job really is to just enter what's in the calculator, right? So I go to my edit. It's already a 3 by 3. We have negative 4, 2, negative 1, 2, negative 1, 3, negative 2, 3, negative 2. And then you can double check that that's right. So negative 4, 2, negative 1, 2, negative 1, 3, negative 2, 3, negative 2. And then I'm going to quit out, go back to my matrix, go over to edit, pick B, right? And now I have a negative 3, a 6, sorry, negative 6, my bad, and a 1. And you should always double check because it's the worst if that's the reason you get something wrong. So you quit out, and then I already have A inverse times B, so I just hit enter. Now they're not always going to be nice, happy numbers. Sometimes they're fractions, sometimes they're decimals, whatevs. But that's the gist, right? So there's my answer, and then to answer my question, my x is 1, my y is negative 1, and my z is negative 3. Cool. All right, moving on. So we're going to talk about what happens if something's not possible, right? So hint, hint, wink, wink, nod, nod. They suddenly threw in this thing where they say, classify it if you can, and if it's not possible, say why. So let's make our matrix equation. It's already lined up. Negative 3, 4, negative 6, 8, x and y, 3 and 18. That's not supposed to have a line there, guys. Sorry, I take it back, folks. I don't know what's wrong with my brain. All right, so there we go, 18. So this is your A, this is your B, right? So to find your x and y, you go ahead and do the same thing you've done like 4 times in a row or 3 times in a row, and you do your A inverse times B, and then something's going to go wrong. So let's go ahead and try it. So second, all right, we go to edit. I want A to be a 2 by 2 this time. I have negative 3, 4, negative 6, 8, right? And then I quit out of that, and I go back to matrix. All right, and I'm going to go to B, which is now a 2 by 1, and it is a 3 and an 18, right? And that's right, and I quit out, and then I try it. Uh-oh. So I get an error singular matrix. Now remember, when we talked about that in 4.3, we learned that that means that there's no inverse, right? So when you get this error, the problem is that there is no inverse. And we can actually see why here, because remember, we saw that the determinant is AD, which would be negative 24, minus BC, which would be minus a negative 24, so the determinant is 0, right? So what that means is that it's one of these two special cases. This is either no solution or infinite solutions. Well, the trick is that if it's infinite solutions, so if it's infinite solutions, then they're the same equation, right? It's the same equation. And this is not the same equation, because if you double, so notice how negative 3x and 4y, if you double them, you get this stuff, right? So you double them. So if this was a 6, right? If this were a 6, then I would tell you, oh, this is the same equation, right? Because if you double the negative 3x, you get negative 6. If you double the 4y, you get 8y. If you double the 3, you get 6. So if this were a 6, then they would be the same equation, right? But because it's not a 6, what we're looking at is we're looking at parallel lines. We're looking at same slope because the coefficients of x and y are proportionately the same, and different y-intercepts, right? So for instance, if this had been negative 3x plus 4y equals 3 and negative 6x plus 8y equals 6, well then that would be the same equation, and this would be called consistent dependent, right? And we would have to find the kind of solution, right? We'd say infinite solutions of the form, and then we do the same thing we did in some of the other ones where we're like A and then this other version of what A is, right? But that's not what's happening here. What's happening here is this is inconsistent. There's no solution, right? And the reason that there's no solution is if you were to graph these, right? So this is what's happening in this case. And the reason that that's what's happening, sorry, I've got a bad cough today. I assure you I'm socially distant enough from you via the internet that you're just fine. So if you wanted to solve these for y, you could, right? If you solve these for y, you're going to get 4y equals 3x plus 3. So you're going to get that this y is 3/4 x plus 3/4. And if you solve the other one for y, you're going to have 8y equals 6x plus 18, which means you're going to get y equals another 3/4, because that's what 6/8 is, right? And then this is going to end up canceling some 2's, right? And I'm going to get 9/4. So what you're getting here is you're getting a system of parallel lines that have a slope of 3/4, but have different y-intercepts. One of them looks like this, kind of like just above 0, and one of them looks like this. That's what's happening. These are parallel lines, right? So there's no solution and it's inconsistent. All right, so let's go ahead and try one. You go ahead and try P3. Here they didn't even bother to start you with the equations, but you go ahead and give it a try. Oh, I kind of spoiled this one for you. Oh, well. So same thing's going to happen, but this is exactly the example I just talked to you about, right? If you look at these two equations, that's a y, I bet. They're the same equation, right? So this is accidentally, didn't mean to do that for you. I totally spoiled it, even though that was on the next slide. I just forgot. So they're the same equation for all of the reasons that I just went through here unintentionally. Right, I was trying to show you that they were the same equation. So unintentionally the same equation. So this is going to be consistent dependent, right? And that means that there's going to be infinite solutions. So what that means is that there's infinite solutions of the form. And then what I need to do to find that form is I need to solve one of these equations for y, which I've already conveniently done, right? They are both y equals 3/4 x plus 3/4. So 3/4 a plus 3/4, right? Because I already solved it for that here when I found what this one was, right, in the previous example. So, so again, I didn't mean to spoil P3 for you. Sometimes my brain does that. I apologize. So let's go ahead and I think that that's it. So we saw what both of these look like, okay? So if you get an error like this, it either means that it's because they're the same equation, right, or it means that it's because they're parallel lines. And that's it for 4.4. So in 4.5, we're going to learn a way to do some of this by hand, and you will only hate me a little bit for it. That's a lie. You'll probably hate me lots. It's okay. All right. Bye, folks.